so we have grams. We need to be able to convert grams to moles and moles to grams, and we do this using the molar mass. So those are the values that are on the periodic table. And if we have a compound, periodic table, if we have a compound, we just add up all those masses on the periodic table to get the molar mass of our compound. So grams to moles, okay. We also need to be able to convert between liters and moles. And when we say liters, we're only talking about liters of gas. So we have a different way of converting between liters of liquid, and we'll learn about that in a future unit, but we're only concerned about liters of gas right now. And this liters measures volume. So you sometimes see this referred to as volume of gas. Liters is the unit, and then volume is what we're measuring. Same thing up here. Grams is our unit, and it's measuring mass. I'll put mass at the top, actually, so it's consistent. So mass to moles or volume to moles. And then our third one is we need to be able to convert between particles and moles. Particles. And particles include molecules, atoms, formula units, all that stuff. Molecules, atoms, formula units, which we're going to try not to abbreviate FU, formula units, because that sounds kind of bad when you start having that written all over your paper. Molecules, atoms, formula units, compounds, or it'll sometimes just say particles. So any of these things. We talked about how to get from mass to moles using the molar mass. Volume to moles, we use that molar volume of gas, which is 22.4 liters equals 1 mole. And then to get from particles to moles, what value do we use for that conversion? I'll start writing out the number.
We use whatever his name's number. I can't remember his name.
His name is Avogadro. Avogadro, not avocado. I'm a man, not a fruit. So that's the best way I have for you to remember that. So 6.02 or 6.022 times 10 to the 23rd, and that's how many particles there are in 1 mole of anything. Avogadro's number. Okay? So there's our start. So let's say we wanted to convert 72.5 grams of oxygen gas, O2, into moles. So convert 72.5 grams of oxygen gas to moles. So if we wanted to do this, we'd start with our given value, meaning a number, our given unit, so grams, and then our given substance. So 72.5 grams of O2 gas. So we have to have all three things. And then we're going to multiply by some conversion factor because we're doing dimensional analysis. The tricky part comes when you're trying to decide where to put your units and where to put your numbers. So the units are actually just like what we did with metric units. So we have grams of O2 in the numerator and we need it to cancel out. So we're going to put grams of O2 in the denominator. That way those two units will cancel out. And then we're trying to get into moles. So this chart comes in handy for determining whether you can make the conversion. Well, we have to memorize the chart, or we have one provided on the quiz or test. This chart right here you do need to memorize. So a much more condensed version of it, just write grams, moles, liters, and particles, and then connect them, because then you can count how many steps you need to get between each. So like here, we're going from grams, and we want to get to moles. So grams to moles, that's just one step. So we are just going to need one conversion factor to get there. Does that make sense, Cass? I know we can't hear Cass, so she's typing in. Perfect. So it makes sense. We're good. Okay, so we have grams of O2 on bottom, and we want to get to moles of O2. So I'm going to put moles of O2 on top. Okay. We always fill our units in first because otherwise it's really confusing to try and figure out where to put the numbers. So right now we need to go from grams to moles, and to get there we use the molar mass. So the molar mass is telling us how many grams there are in 1 mole. So O2's molar mass, so the mass of an oxygen is 15.999, so it can be rounded to 16 grams, but we need to multiply it by 2 because we have 2 oxygens. So the mass of O2 is 32 grams per mole. And that's per 1 mole. So 1 mole, I can write this out as like a general statement, is equal to 32 grams of oxygen. 1 mole of O2 equals 32 grams of oxygen. So now that I have this statement, I can use this to make a conversion factor. So I could either put 1 mole of O2 on top and 32 grams of O2 on bottom, or I could use it the other way and put 32 grams of O2 on top and 1 mole of O2 on the bottom. Either way, these are true conversion factors. So we can multiply by either one of these, and essentially we're multiplying by 1 because both of these things are equal to 1. 1 mole of oxygen is equal to 32 grams. So when we divide those things, it equals just 1. So we can multiply by it. So which one of these two conversion factors, I'll label them A and B, which one do we need to use in this equation? And Cass, you can type an answer if you can't talk as well. So think about where we need our moles and grams. So in our conversion factor, where is our moles supposed to be? It's supposed to be on top? Yeah, it's supposed to be on top. So which one of these conversion factors has moles on top? So we're looking just at these two conversion factors that I wrote, and A has moles on top, so this is what is going to end up in our equation. So we don't necessarily need to write both these out like every single time, because we already knew that moles was on top and grams was on bottom. We just need to be able to pair up these numbers correctly. So 1 is going to go next to moles, so 1 mole of O2 on top, and then the 32 is going to go next to the grams of O2, and that's on bottom. So in this case, we have 1 mole of O2 over 32 grams, which is this first conversion factor. But if we were converting from moles to grams, so let's say we did it the opposite direction, if we were doing 1 mole of O2 and we wanted to convert it into grams of O2, then we'd have moles of O2 on bottom and we wanted to convert to grams. So we'd use this other conversion factor, 32 grams of O2 over 1 mole of O2. So it just depends on what direction your conversion's going. So that's basically how you decide what to do. Are we good so far? Anybody need me to stop?
I'm good. I actually have to go to dinner.
Okay.
So I'm very sorry to be skipping out.
You're fine. If you have any more questions, let me know. Yeah. And Cass, we'll keep going. So if we divide this out, 72.5 divided by 32, let me get my calculator, I can't do that in my head. So 72.5 divided by 32, our units cancel out, so we have 2.2656, but I'm going to round this to 3 significant figures because of the 72.5. So 1, 2, 3 significant figures. This 5 will make the 6 round up to a 7. So my final answer will be 2.27 moles of O2. Cass, does that help? Do you have any other questions? Or do you want to do one more example? Let's see, I'm going to move this page up a little bit. Still confused on compound conversion. Okay, let's do one with a compound. So let's say we want to know, let me switch colors so it's clear where my work stops and begins. So let's say we want to know how many, grams are in 2.67 moles of calcium bromide. Cass, is this the kind of problem you're talking about? Okay, perfect. Okay, so 2.67 moles of calcium bromide is our given value, 2.67. Our given unit is moles, and our given substance is calcium bromide. But before I write that out, I don't want to have to write calcium bromide out every time, so I'm going to go ahead and do my crisscross to figure out my formula. So we have Ca and calcium. If you look at your periodic table, it's in group 2, so it has a +2 charge. And then bromine, Br, has a -1 charge. So when we crisscross, we get Ca1 and then Br2. So now that I have this formula, now I'm going to write out my given value, unit, and substance. So as I can do 2.67. The abbreviation for mole is still annoyingly long. It's MOL, so you save one letter, which is kind of silly, at least to me. But 2.67 moles of CaBr2. Okay, and we want to get to grams. Grams is what the problem is asking for. So to get from moles to grams, we're just going to need one step, and we're going to use our molar mass to build our conversion factor. Okay, so back down here, let's see, so 2.67 multiplied by a conversion factor. Our unit that's going to go on bottom is the one we want to cancel out, so we're going to put moles of CaBr2 on bottom, our unit and our substance, and we want to convert to grams of the same thing. So grams of CaBr2 goes on top. So now to figure out the mass, the molar mass, we have to look at our periodic table and add up the masses of one calcium atom plus 2 bromine atoms. And we know that once we do that, we'll have the mass of 1 mole of calcium bromide. So I'm going to go ahead and fill in my 1, but I know I'm going to need to look at my periodic table to figure out the mass. So calcium, we have 1 calcium, we have 2 bromines. Calcium's mass is 40.078. Okay. And then bromine's mass is 79.904. Okay, and I don't think I left myself enough space, so this is going to be 40.078 plus 2 times that. So let's see. 2 times 79.904. So that's 159.808 plus that part, plus 40.078. So I total, I'm just going to write the total here. It's not that part. This plus this gives me a total of 199.886. So that's what I'm going to put as my molar mass of calcium bromide. So I know there's this many grams in 1 mole, equals 1 mole for calcium bromide. So 199.886. Cass, any questions? Are you good? Okay, cool. So moles of calcium bromide cancels out. So we're just going to be left with grams of calcium bromide. And that's a good thing, because we were asked for grams of calcium bromide in the problem. So now we just have to type this in our calculator. So we needed to do 2.67 times 199.886. So I'm just going to take my previous answer. Alright, it gave me 533.69562. But I know I need to round to just 3 significant figures, because the problem has 3 significant figures in this 2.67. So 533, we're going to stop here, and the 3 is going to round up to a 4, because the 6 would make it round up. So we're going to round to 534, and our units are grams of CaBr2. How are you feeling about that, Cass? Okay, so here's our problem. So we first need to start by figuring out our given value, our given substance, and our given unit. So this isn't totally clear in this problem, because it says how many grams of barium hydroxide's up here, are in 9.86 times 10 to the 23rd formula units, and it doesn't say specifically of barium hydroxide. But since it doesn't tell us that it's a different substance, it's pretty safe to assume that it's still barium hydroxide. So I'm going to actually write that in here. So I'm going to underline my given value, my units, and then I'm going to add in my substance. So I'm going to go ahead and do my crisscross. So barium has a +2 charge, and then hydroxide is OH with a -1 charge. So when we crisscross, we get Ba1, and then we're going to end up with 2 OHs. So I'm going to open parentheses, close parentheses, and put my 2 outside. So now I'm going to put that in here so I don't forget to use it. BaOH2. I always like to have all my information written down in one place just because I think it makes it a little easier to keep track of the problem. Because once you start doing stoichiometry and stuff, there's just going to be a lot of substances and a lot of values. And it's not that it's really any harder than this, it's just that there's a lot to keep track of. So the more organized you are, the easier it will be for you. So now we have this whole thing, and we're going to write it out so we can start doing our stoichiometry. I'm going to move this out of the way for now so we can have more space. So 9.86 times 10 to the 23rd. Remember, we shouldn't abbreviate formula units, so formula units of BaOH2. Okay, so we have that. We know we're going to multiply by at least one conversion factor, but we need to know how many conversion factors we need here. So let's take a look at our chart. So we want to know how many grams, and we're starting in formula units, which is one of our particles. So if we're going from particles to grams, this is going to be 1 step, 2 steps. So we're going to need 2 conversion factors to make this unit conversion. 1 to go from particles to moles, and then 1 to go from moles to grams. So let's keep that in mind when we're setting this up. Our first conversion factor is going to take us from formula units, which is a kind of particle. So formula units, still of BaOH2. It's going to take us formula units into moles. So we want to end up in moles of BaOH2. Okay, so that's our first conversion factor. And then our second conversion factor, we need to go from moles to grams. So moles of BaOH2 is going to go on the bottom and cancel out. And now we want to wind up in grams of BaOH2. Okay, so just to double check, we can go in and make sure all our units are going to cancel. So formula units will cancel with this formula units, that makes sense. Then moles will cancel with the moles down here, and we'll be just left with grams of barium hydroxide, which we can look at our problem and it says how many grams of barium hydroxide. So that's exactly what we want to be left with. So we know we've set our problem up right. Now we just need to fill in some numbers. So for the number of formula units in a mole, any kind of particle, there's going to be 6.02 times 10 to the 23rd of that particle in 1 mole. So we can write it out as an equals sign first if we want to. So 1 mole is always equal to 6.02 times 10 to the 23rd particles. So here I want to put my number 1 next to my mole, so moles, so I'm going to put my 1 here, and then my particles are my formula units. So my formula unit's a kind of particle, so I want to put the 6.02 times 10 to the 23rd next to the formula units. 6.02 times 10 to the 23rd power formula units. Perfect. Okay, so that's our first one. Now we need to figure out how many grams of barium hydroxide are in 1 mole. And to do that, we just refer to our periodic table. We're going to add up the mass. So we have 1 barium, we have 2 oxygens, and we also have 2 hydrogens. So the mass of barium is the one I don't know. Let's look that up. Mass of barium is 137.327. Okay. Oxygen's mass is approximately 16. It's 15.999, but we can round to that one. So 2 times 16 will give me 32. And then hydrogen is approximately a mass of 1. It's 1.008, but we can round that to 1. So gives us 2. 2 times 1 is 2. So then if I add up these three numbers over here, I add these up. So let's see. 137.327 plus 32 plus 2 gives me 171.327. And now let's just think real quick. This is a number of grams because this came from our periodic table, and all those molar masses are numbers of grams. So that's the number of grams that's equal to 1 mole of barium hydroxide. So for barium hydroxide, there are 171.327 grams equal 1 mole. So my 1 is going to go next to my mole. And then this 171.327, that's going to go next to my grams in my problem. So 171.327 grams over 1 mole. Okay, so now we have the problem set up. We just need to do our math. And people tend to mess up the most with entering into the calculators when we have exponents. My tip to you is to put everything in the denominator in parentheses. So put I don't know if I'm spelling this right. Denominator in parentheses. That tends to get rid of a lot of the misreads by your calculator. So I'm going to show you how I would enter this in. Let's move this up a little bit so this can be in the light. So let's see. Oh, I'm trying to make it show the calculator screen. So we have 9.86. And then we're going to hit our E button, e to the 23rd. And then I'm going to multiply by the thing on the top, so times 1 is still the same thing, so I'm not going to put that in. But times 171.327 times 171.327, okay? And then I'm going to hit enter to get that first answer done. And now I'm just going to hit the division sign, and divide by what's in my denominator, which is the 6.02 times 10 to the 23rd. But I'm going to open a set of parentheses and put 6.02 e to the 23rd, close parentheses, and then hit enter. So that gave me, I'm going to write it down here because I don't have enough room. That gave me 280.61199. Carry off that number as far as you want, but we need to round it to 3 significant figures, like our given value. So 28, this is our third place, and the 6 makes it round up to a 1, so we'll round it to 281, and our units are grams of BaOH2. Anything else we want to go through, Cass? Sounds good.